Thank you, Jerry. It is always a pleasure to come to Long Beach Aquarium. It is, it's a very special place, and I've been here 6 or 7 times now, and I really enjoy the aquarium itself. I especially admire the amazing programming that you have, and we all admire Jerry. You know him from the aquarium, but I've known him for a long time, and he is one of the true leaders in oceanography, not just aquarium oceanography, but the big broad world of oceanography. And he's a real treasure. I know he's a treasure for you, and he is for all of us as well. And so this will be the lead up to the second talk, which, you know, with a Second City graduate is bound to be really interesting. I'm looking forward to that. So Jerry asked me to talk to you about not so much, you know, making a prediction about what the future ocean would be like, but to talk a little bit about how we would interact with it, and really asking the, whoops. All right, let's try it that way. Sort of asking the question, will we manage the ocean? And my answer is, I think we will try. And I'm going to talk to you a little bit about that idea of all of us deciding that we want the ocean to be a certain way. And you sort of see it play out in people who say, you know, the ocean used to be like this. We need to do something to get back there. That says we want a certain kind of ocean. And what is it? You know, whenever you manage something, you know, there's that issue of what is the goal. So I'm going to talk to you a little bit about some of the elements that we might consider managing. And I'll talk to you a little bit about, I'm going to use fisheries as an example of what I think might happen, and then talk a little bit about what's necessary for that. So what do I mean by ocean when I say manage the ocean? I'm going to look at it from a big sense, you know, that whole big blue space on the planet, not just the coastal ocean or our estuaries, but think about, you know, the kinds of conversations people are having about the ocean in general. And in general, when we talk about what we mean by the ocean, we're probably talking first and foremost about resources and uses of the ocean. And this is also kind of a fraught idea. I was at a conference in Europe that was about the oceans, and I was a guest speaker at a side session, and I said, you know, we need to think about sustainable use of the resources of the ocean. And the next speaker got up and said, we should never be talking about the ocean as a resource. You know, it's like it's our home, it's our, you know, our watery origin and everything. So even thinking about something like this is a loaded term for a lot of people. You know, do we use the ocean? Well, we do. Should we use the ocean? So some of the things that we're used to using the ocean for are fisheries and space for aquaculture. Biodiversity. We are used to being able to collect organisms that have unusual characteristics or that make molecules that are useful. There are about 22 different drugs that are either being used or are in clinical trials that are, whose origin is with marine species. There are a lot of other things. People are using, for example, the mussels, where you have to work to get that black byssal thread that's attached to the mussel and that attaches it to the bottom. And there are a lot of properties of that are being studied because it's exceptionally strong and resists breaking. So we're used to thinking about being able to use those elements of biodiversity. We certainly think about oil and gas and other kinds of energy resources. This is the first active commercial wind farm in the ocean. It's off Rhode Island. You can't see it from shore. It's 7 miles offshore. A new area that people are talking about is actively mining things from the ocean. Now, there were thoughts about mining manganese nodules from the ocean. A manganese nodule is an object that's about the size of a potato and maybe sort of flattened, dark brown. It's highly enriched in the element manganese, also iron, but more importantly in a lot of trace elements like copper, nickel, zinc, cobalt, that people would like to use as an alternative to mining on land. A new idea is mining the sulfide minerals that come out of hydrothermal vents on the ocean. There's actually a Canadian company, Nautilus Mining, that is building the infrastructure to be able to do that, and would be starting work off New Britain, which is in the western equatorial Pacific. Water resources. So that's the Carlsbad desalinization plant. And there's a lot of talk about that in California. And every time we have a drought that lasts more than 2 years, there's more talk about it. So we're used to thinking about that as another resource. Transportation. So that's Port of Long Beach. And global trade is marine trade. 97-98% of international trade is marine trade. So we're used to being able to use the ocean for that, and for all kinds of marine transport related features. So those are all resources. What about characteristics? So if we were going to manage the ocean, are we going to try to manage sea level to prevent sea level rise? Or you hear a lot about ocean acidification. Would we try to manage the pH or the level of acidity of the ocean or the amount of oxygen or its temperature? We're worried about the ocean's temperature increasing. So this is kind of the constellation of things that people are talking about when they talk about wanting to manage the ocean. So what do we mean by manage? That's the dictionary definition of manage, but we're really talking about managing human behavior affecting the ocean rather than managing the ocean itself. We're not talking about changing the way that wave energy is dispersed in the ocean, but all of these things that are really our footprint, and therefore we'd be talking about managing ourselves. Historically, we've had some roles in that. We've tried to manage the amount and location of fishing and aquaculture by doing stock assessment and and trying to limit the amount of fishing or specify where fishing would take. We've limited the exploitation of oil and gas, at least in countries' EEZs, to specific locations. We've talked about specific locations for mineral extraction, location of desal, and so forth. So we have tried also to manage characteristics, especially biodiversity. So in the same way that there is an international group, the UN Framework Convention for Climate Change, that has annual meetings, conference of the parties, that resulted in the Paris Agreement, there's a similar international UN body called the Convention on Biological Diversity that seeks to manage that characteristic of the ocean, its biodiversity, primarily by trying to limit the several aspects of taking organisms from the sea. We probably the one that you've heard of most is the convention that deals with endangered species, CITES, and that, just as you hear about it with respect to the rhinos or the elephant, there are species in the ocean that are controlled by CITES. But even more, there are many aspects of the biology of the ocean that are under discussion for management. There's a huge part of the negotiations that deals with what's called biodiversity or biology beyond national jurisdiction. So that's talking about the big blue ocean, far from land, and trying to put restrictions on that. And some very interesting approaches to that. In coastal waters and in EEZs, establishing marine reserves and marine protected areas, biodiversity beyond national jurisdiction, which I mentioned. And in the same way that the law of the sea said, we'll try to manage the deep ocean by saying you could only mine manganese nodules or whatever else in certain places where you had a lease and it's the global commons, so you have to have international permission to work there. Biodiversity beyond national jurisdiction is now saying maybe we'll restrict the collection or the use of organisms collected from the open ocean. And they're not just talking about fish, they're also talking about collecting samples that you would use for looking for various genetic traits or molecules, whether that's drugs from the sea, etc., that you wouldn't be able to take a sample and then make a product from it without getting permission at an international level. So those are some very interesting things that are going on, and that's all aspects of our effort to manage the oceans. So I think that one of the things that's really going to push managing the oceans even further is the Paris Agreement. Now that agreement is trying to manage a characteristic of climate, the tropospheric temperature. And the whole agreement is focused at trying to keep the temperature of the troposphere, the part of the atmosphere that we live in, to have a maximum that is no more than 2 degrees of the average of the pre-industrial. That 2 degrees was not a consensus of the scientific community. It was a consensus of the political community. So all of a sudden, when you start, I wanted to give you those examples from the ocean so you could see, in some ways how audacious that goal is. We're going to manage the temperature of the Earth by reducing emissions, et cetera. And I think it's really important that we set out to try to do that, but it is as audacious to try to do that purposefully as it is to say we're going to manage some part of the ocean. So I think that managing climate character is the thing that's going to give us the audacity to say, okay, we're going to manage the ocean. And it will, of course, depend on how successful we are with managing atmospheric temperature. But I think that if we start seeing some success there is going to be a sense that we have the knowledge, the skill, and the ability to go out and start looking at characteristics of the ocean. I think that that's a really fascinating thing, and I think in many respects it's a very scary thing because of what we don't know about the ocean and how complex it is. So, what do I mean by we manage the ocean? We'd probably have to work at multiple levels, but I'm going to talk a little bit about the way that international agreements for managing big things related to the ocean and the climate work. And I'll give you some thoughts that I have, but I'll let you also be the judge of whether you think that they give you the confidence that we would be able to do that. Some examples of international management that have worked. And I'll talk a little bit about the Montreal Protocol and the London Dumping Convention. And I gave you my grades. I think Montreal Protocol gets an A. And I'll tell you a little more about both of these. And the London Dumping Convention I give maybe a C minus. So the Montreal Protocol is an international agreement that manages the amount of chlorofluorocarbons, man-made molecules that we used primarily for refrigeration primarily for refrigeration, but other uses as well. And of course, those of you who are my age know that in the 90s, we sort of woke up to the fact that the ozone concentration in the upper atmosphere was decreasing, and that the size of that hole in the ozone was increasing. And the risk was that the ozone was what protects us from the most harmful radiation from the sun. So left unaddressed, the projections were that this would soon extend into temperate latitudes and that we would be facing very harmful, the most harmful rays of the sunlight. So this protocol was focused on managing the amount of those artificial compounds, chlorofluorocarbons, to be released in the atmosphere in order to restore the ozone layer. And I think that there were really two keys to success. The first was that we were talking about something that addressed a northern hemisphere developed world problem. So we weren't talking about something that was going to affect people that didn't have a lot of resources to be able to address it. And we were talking about, think about the temperate latitudes of the northern hemisphere and all of the developed world. The second key to its success was that there was an alternative compound available. It wasn't being widely used, but it was available. So there was a plan B that was fairly easy to turn to. And this year marks the 30th year of the Montreal Protocol, so caring for all life under the sun. I don't know if I would characterize it that way, but and here's a little graph that will give you some sense of how successful it was and why I gave it an A. So this is 1950 to 2100, and each one of these curves is a chlorofluorocarbon that was responsible for decreasing ozone. And you can see that some of them were man-made compounds that just weren't even being used in the 50s. And then some were naturally occurring compounds. But by about 1990 here, when people started worrying about the chlorofluorocarbons, you can see that the concentration of these was rising very rapidly. And the negotiation took place and had as its goal to turn that curve around. And here we are, the last dots on here are from about 2007, and you can see that for several of the compounds, it already, has decreased. And this is the concentration in the atmosphere, not the amount that we're putting in. So we actually were putting in very little now, but it takes a long time for the atmosphere to respond. So I gave this an A. There was tremendous agreement. It was put into place very quickly. There is great compliance with the Montreal Protocol, and we've already started turning the curve on those. So that's an international goal to try to affect human behavior to get at a characteristic of the atmosphere, and it's pretty much working. Another example that I'll give you of international cooperation is what we call the London Dumping Convention. It's actually called the London Convention, and it manages the amount of a wide variety of different materials that can be released into the ocean. Everything from pesticides, herbicides, garbage, plastic, you name it. And what it tries to do is to prevent pollution of the ocean by reducing the amount of release into the ocean. So this little curve is just from 1990 to 2010, the amount of maritime dumping. And it's not, so 1990, and then it jumps to 2000, 2005, and then 6, 7, 8, 9, 10. So you can see that in the 90s, we were increasing the release of many kinds of materials into the open ocean. And that's when the London Dumping Convention, which was agreed to in 1992, started into force, and it was trying to turn the curve. And it has turned the curve a bit. But the key shortcomings of this are that not all nations are parties to it, and there is a real lack of compliance in the developing world. And much of what you hear about the idea of plastics in the ocean is an example of the inability of the London Convention to get agreement on how to prevent release. And there's also a lack of enforcement. And there was enforcement with the Montreal Protocol. So yes, they've done some work, but each year there are more new things that become an issue for things that are dumped into the ocean. So this would not give us a lot of confidence that we could manage ourselves and manage the ocean. Some examples that absolutely did not work. The Kyoto Protocol, which was the first attempt to try to manage carbon emissions. And I gave it a D-. Carbon emissions kept going up during the whole time the Kyoto Protocol has been in force. It had almost no effect. So it tried to do that through carbon markets and their equivalents and voluntary compliance. And the key to its failure was that it didn't require developing nations to participate. So it's sort of like the Montreal or the London Dumping Convention in that sense. It didn't require everybody to be a part of this. And then some very interesting things that are under development. So we now have an acceleration of voluntary establishment of marine protected areas. And in the last 5 years, we've gone from less than 2% of all of the little yellow splotches here are protected areas. We've gone from less than 2% of the ocean in protected areas to almost 6% in 5 years. And this doesn't even include a couple of absolutely huge areas off of Chile and several island states that have been designated just during 2017. So it's not, it's not a third of the ocean. There are different nonprofit organizations have different goals. Some of them feel that 30% of the world ocean should be protected. Some of them say it has to be much more than that. But it's very interesting that so many areas are voluntarily protecting areas of the world ocean and creating marine reserves as well. So that might, that's a different kind of protection. What I'm trying to give you a sense for is the range of tools that are out there to think about managing the ocean. And the last one that I want to mention is the International Seabed Authority, which is attempting to manage seabed mining under the Law of the Sea Convention. So what they're doing is establishing mechanisms for regulating mining beyond national jurisdiction, outside of EEZs. And they have, this is a little map of the central area of the Pacific, and each one of these little irregular areas is a lease for a nation that has an international agreement that they can mine for manganese nodules in that area. So this is meant to restrict the amount of mining that can take place, to concentrate it into certain zones, and then there are a variety of environmental impact assessments that have to be done before any mining starts. There's no actual mining taking place. They're still very much in the area of trying to do environmental impact assessment. And then mining of hydrothermal systems that I told you about. And the thing that's different here is that many of them are in the EEZ of individual nations. So the first mining that is scheduled to take place is in the EEZ of Indonesia. And so this Canadian company is working with Indonesia in Indonesian territorial waters. So that's another area that's just sort of under construction in terms of management. And then the big one that we're undertaking is that management of the release of greenhouse gases to limit the maximum tropospheric temperature. And if you put all of the voluntary agreements that are now on the table together and look at whether they would reach that goal of keeping warming to less than 2 degrees, they fail miserably. The goal is to, it's sort of, their philosophy is you have to walk before you can run. We'll put voluntary limits there as technology improves and as the cost of renewables go down, people will put more and more voluntary contributions on the table. And sometime down the road, that we'll start talking about the idea of having certain limits on this, so that you would be limited in the amount you can emit, but not at this point. So kind of a mix, you know, some things that are fairly strict and have worked to get to a certain result. Some things that are pretty loose, some things that are ambitious but have no track record. And so why would I think that that we're going to start talking about doing it? The main reason is that I think that this is the century in which we are really going to be able to densely observe the planet and include in that the ocean. And that means that if we're observing, we have the opportunity to measure and detect and also see other people's activities. So the example I'm going to give you is from fisheries. And this is now a little bit out of date. It's this is from the 1950s to 2005. And this is the percent of fish stocks that are underexploited, fully exploited, overexploited, and that have crashed. So in the 1950s, when I was a little girl, almost 85% of global fish stocks were underexploited. We weren't even coming close to lack of sustainability in our fishing. By the 70s, that was almost 50%, that it had gone down to almost 50%, and a big chunk, about 35%, were fully exploited. We were taking everything we could, but not overexploiting them. And the picture has really changed since then. So we have virtually no commercial fish stocks that are underexploited. We have about 30% that are fully exploited, and the rest are overexploited or crashed. So in terms of the ability for us to get protein from the oceans, this is really a very, very concerning picture. And when you consider that we have about 6.5 billion people on the planet, about 2 billion of them depend on fish or seafood for their primary protein source. And a goodly portion of those are some of the poorest people on the planet. And those fish stocks that are for artisanal fishing are also moving into that overexploited phase. Um, this shows you a comparison of fishing versus aquaculture. The dark blue is fishing. This is from 1950 to about 2015. So you can see that even with all the fishing that's going on, we've leveled out in terms of production of fish, and that aquaculture is starting to take off. So that's a challenge in terms of where are we going to put it, and will we be able to generate enough protein from it to make up for what we are starting to lose with fisheries. And the last of those that I want to show you, so a little complicated. The brown curve at the top is world population. So this was 2002, it was 6.5 billion. It's well on the way, almost 7 now in 2017. The blue is the dark blue is the world fish catch. The dotted line is the world fish catch with China, and the reason that it's dotted like that and not included is that the data is so bad because China does not report its fishing with as much accuracy as other countries do. The orange curve is aquaculture, and the green is kilograms of fish per capita. So that includes all of that increase in aquaculture. And basically what you're seeing is even with all the effort that we have, we're flattening out. And if you consider the increase in population, this is a real food security problem. And I personally think that this is the problem that's going to drive people toward getting serious about managing in a global way. The big U.S. now global food giants, Cargill, Monsanto, are actively investing in all sorts of algal production of protein because they know that we're already flat with production of protein on land. We basically can't do anything more. And we flattened out with production of protein from the ocean. So how do we feed protein to the 9 or 10 billion that we'll have by after the century? That is the food security problem on the planet. It's all wrapped up around the ocean because of all that artisanal fishing. And I think that that's one of the main things that's going to drive people to say, we've got to get real, we've got to manage it. And to manage something like this, if that were as successful as even the London Dumping Convention or the Montreal Protocol, would be the first time that we had done something like that as an international community. And it's right smack in our oceans. The fish stocks in the EEZs of developing countries have moved toward, but have generally not achieved sustainability. So that's what's driving aquaculture. And the big issue that is wrapped around this as well is illegal, unreported, and unregulated fishing. It's called IUU fishing in global terms. Between 13 and 30% of the fish consumed, depending on the species and where you are, is illegally caught. And here in the US, between 20 and 30% of the fish you eat was illegally caught. That's how big the problem is. And we think that we are pretty good about control. So what's happening with this, and this, what I'm trying to do is walk you into some of the ways that people are thinking about managing and what it would take to take on a huge issue like this. So there's several elements to how you can manage illegal fishing. And I looked for some kind of a graphic that would give you some sense of how global a problem this is. And I really couldn't find one, but the fishing in the world ocean is truly global. So this whole region of the equatorial Atlantic is dominated by Spanish fishing. The entire equatorial Pacific is dominated by Japanese fishing. The North Pacific is dominated by Korean and Chinese fishing, but all of those go far afield. So there are Japanese fishers out here, especially for tuna. There are Spanish fishers in the Pacific. Fishing is a global enterprise. It's not, you know, Japan fishing around Japan. And the illegal fishing is also global, and it tends to focus on some of the areas that are least well patrolled. So middle of the Pacific, middle of the Indian Ocean are incredibly populated with fishers. And if we put dots on the map for all of the boats that are out there fishing, which was what I tried to find and couldn't find, you would find every major area where there were fish to be totally covered with dots. So in that mess of legal and illegal, how do you address the problem of illegal fishing to start dealing with overfishing? So there are three elements. One is what's called the vessel automatic identification system. So this is every one of those ships that are in the port at Long Beach have a device on them that's sort of like the black box on a plane that communicates with satellites and gives the position of the vessel. And it is in place largely for safety, wasn't for monitoring. If they have a problem, you can find out where they are. But virtually all of the legal fishing have vessel automatic identification system beacons. And because of the safety issue, many of the illegals do as well. More than half of them have vessel identification systems so that somebody can find them if they run into trouble. Because again, the fishing is global. It's open ocean. We're not talking about being 20 miles offshore. The second piece is what's called a vessel monitoring system. So if you put that together with a satellite ability to monitor that and look at mapping that, which is happening, you can actually monitor all of those vessels around the world. And there are two big efforts. One is called SUMO, and I think I've got SUMO is the European effort. It's the search for unidentified marine objects. So it's, but it's really the search for vessels that are fishing illegally. And the other is a U.S. effort, which is called the Global Fish Watch. And it is sponsored by Google, the Pew Charitable Trusts, and Oceana. Both are using the power of the satellites and the power of the of information systems to be able to track vessels and to be able to see that they're fishing. And so there'll be a very characteristic, let me go back to this. You'll see a very characteristic pattern. They track the beacon, and the ship will go out, and then you'll see it. It'll go out fast, and then you'll see it going up and down and back and forth or in circles, and that's the fishing activity, and then it goes back to shore. So normal transport vessels go from one place to another. So that's the giveaway that they're involved in fishing. And then using the AIS system, they can tell whether it's legal or illegal. This is an image of the Indonesian Maritime police burning a whole fleet of illegal Vietnamese fishing vessels. So they impounded them, they took them over, and they just burned them right in the on the high seas. And that's so that's the result, or huge fines or confiscation and destruction of these vessels. The second piece of this is, okay, so now you know that they were fishing, but they're already in port and they're selling that fish, and that's how it's getting to us. So a couple of things that are going on are major developments in terms of using the genomics of fish to be able to track them. So in addition to just the fact that they're illegal, a very substantial portion of the fish that's in fish markets globally, and a significant fraction in the U.S. is not the fish that we think it is. So this is, on this side, are pictures of the fish that is what people think they're buying, like salmon and swordfish and flounder and rockfish. And on the other side is what's actually being sold to them. It looks very similar, but it's a different fish species, a less desirable one, and one that is easier to catch illegally. So some of the answer to this is being able to very rapidly do DNA analysis of the fish to determine that it's illegally caught substitute fish. A second major thing that's going on is the tagging of fish stocks. So legal fishers can put essentially RFID tags on their catch so that the fish wholesalers know that they're buying a legal product rather than an illegal one. So this is a combination of that ability to observe the ocean intensely together with modern tools of genomics in order to go back and solve what is essentially a fisheries collapse issue. I just wanted to go through that example to show you how some of the things that we have developed for other purposes are being used to address this problem of managing the marine environment. So you can imagine how we might start partially managing other areas, dumping emissions, et cetera. And I want to stop there because I want to give you some time to ask questions. But I think that the key to all of this is really the explosion in our ability to observe the ocean, whether by satellite, whether by autonomous vehicles, whether we're observing it through the genetic material in the ocean, or we're observing it through being able to monitor vessels. All of it is tied to this question of could we manage the ocean? And by that I really mean, could we manage our behavior? And I think that some of these big issues of something like fisheries are going to be the tipping point to say we will need to manage, and that will give us a lot of impetus to start thinking about all of the other kinds of things that we might manage as well. So I'll stop there. Thank you.